Example 2, find values of x, if any, at which f is not continuous. Part A. In this question, we have cube root of x minus 8. And we know if we have odd root, it accepts any value, positive, negative, or 0. So, for this function, there is no values in which f is not continuous there. So this is continuous everywhere. Or we can write continuous on all real numbers R. For part B, we have f of x equal x plus 2 divided by x squared plus 4. This is a rational function, so you have to check the denominator and put it equal to 0. So x squared plus 4 equal to 0. And if we move 4 to the right hand side, you will get x squared equal to negative 4, which is unacceptable. So there is no values of x where f is discontinuous. So this function is continuous everywhere also, because we don't have any zeros of denominator. In part C, also this is a rational function, so you have to put the denominator equal to 0, x minus 4, x squared minus 4 equal to 0. And by solving this one, you can take negative 4 to the right hand side, or you can factorize this binomial. You will get x squared equals to 4, and by taking radical for both sides, you will get x equals negative 2 and 2. So these are the values of x where f is not continuous or discontinuous. Part D, we have two rational functions. We have the sum of two rational functions, so you have to deal with them separately. This is the first function, and the first denominator is x, so you have to put x equal to 0, and this is the first value where f is not continuous. Secondly, we have the second denominator, which is x squared minus 1 equal to 0. By moving negative 1 to the right hand side, you will get x squared equals to 1. By taking the radical for both sides, you will get x equals plus minus 1. So the values of x that f is discontinuous or not continuous, f is discontinuous for x equals 0, negative 1, and 1. Next, we have this function. Also, this is a rational function. For numerator, we have only a polynomial, and as we know that polynomial is continuous everywhere. In denominator, we have absolute value of x plus 3 equal to 0. By moving 3 to the right hand side, we have absolute of x equals to negative 3, which is incorrect statements. So there are no zeros for denominator, and hence f is continuous on R or everywhere. There is no values of x that f is not continuous. For part F, we have an absolute value. This is a composite function. 4 is a constant function, it's continuous everywhere. For the second function, we have a rational function. The denominator is x to the power 4 plus x equal to 0. Take the greatest common factor between the two terms. We have x multiplied by x to the power 3 plus 1 equal to 0. Then you have to factor x power 3 plus 1 because it is sum of two cubes, 1 to the power 3. So it will be x multiplied by x plus 1 multiplied by x square minus 1 times x plus 1 equal to 0. This function is a quadratic function. As a homework, find the discriminant delta b square minus 4ac, and you will see that delta less than 0, so there is no root for this function. So we have two functions, x multiplied by x plus 1, each of them equal to 0. So we have x equal to 0 and we have x equals to -1. These are the value where f is not continuous. So we have -1 and 0. The function f is discontinuous. On part G, we have less than 4 and we have greater than 4. Less than 4 means 4 from left, and greater than 4 it means 4 from right. So we have to check firstly if the function f is continuous at x equals to 4. So limit f of x when x goes 4 from right equals 7 plus 16 over 4, which is equals 11, and limit f of x when x goes 4 to the left equals 2 multiplied by 4 plus 3. You have to substitute on the first function, and 8 plus 3 equals 11, and since we have less than or equal to 4, so 4 is defined in the function, and f of 4 equals to 11. So f is continuous when x equals to 4. For the first function it is a polynomial, so it is continuous in its domain. For the second function, we have a rational function 16 over x, but if we take the denominator x equal to 0, you will find 0 not included on the domain of this function, because in this region we have x greater than 4, and the 0 of denominator here is 0, and 0 is not greater than 4. So 0 is not included with the interval of this function. So we cannot take 0 as discontinuous x. Okay, so for this function in part G, the function f is continuous everywhere, and there is no point of discontinuity. So f is continuous on R. For the last one, we have x not equal to 1 and x equals to 1. So f of 1 equals to 3, because when x equals to 1, f of x equals to 3. Then you have to find the limit of the function. So limit of the function will take it from x not equals to 1. From here we take the limit, and not equal to 1 it means greater than 1 or less than 1. So not equal means to the right and to the left together. Okay, so limit f of x when x goes to 1 equals a 3 over 1 minus 1, which is a 3 over 0. That means the limit does not exist. So since the limit does not exist at x equals to 1, then f is not continuous at x equals 1. This is the value of x where f is discontinuous.